So, if everybody can hear me, I will just double check to make sure. There we are. Hopefully everybody was able to watch the video that I put up. As you'd have noticed, it is the same guy as last time in terms of the video that you watched about erosional processes and the kind of basic formation of some of these landforms. Like we said at the time, it kind of saves us all a bit of time and energy if those sorts of things are already put together for us. So it's not something that we'll be doing every single week, but just while there are a couple of videos that we can use, we may as well make use of them. Now, there's a few things that become really important in terms of what he was talking about on the video, especially as we start thinking about some of these features of our coastline in a little bit more detail. And in particular, the idea of how not only different rocks erode at different rates, that's a relatively simple concept, but things like the orientation and alignment of rocks on our coastline. So where he talked about rocks being parallel or perpendicular to the coastline in terms of concordant and discordant coastlines, and also how those rocks are what we call bedded. So when we have rocks that are aligned nice and straight as you go up a cliff, giving you a very, very steep kind of sheer cliff face, compared to when rocks are dipping slightly either towards the sea or towards the land. And when we start talking about coastal management in a couple of booklets' time, that's really where that idea of bedding and dip comes into play, because it dictates how strong or how vulnerable our coastlines are. Now, in particular for today, that idea of rock alignment becomes quite important. So the idea of whether you have what we call a concordant or discordant coastline. Now, there is some stuff in the booklet about this in the kind of geology section. It's under geological control. Talks about the idea of rock type and differential erosion, but then also talks about rock orientation, excuse me, as well. Now, the little image that you have up on the screen at the moment is a perfect kind of example of an area where we have these discordant and concordant coastlines actually right in the same place. This is the Isle of Portland in Dorset. This is, if the world was normal and we were able to do our Dorset trip like we do every year, we would have actually stayed down in Swanage Bay and had a little bit of a look at all of these places that we're going to go on to talk about. But whenever you hear the idea of a discordant coastline, that's really this kind of right-hand stretch of coast. You can see you've got hard limestone, soft sand and clays, which sandwich a kind of hard chalk region. And if you look at the way that these are aligned to the coast over on this right-hand side, they're all at right angles. They're all perpendicular to the coastline itself. That is what we refer to as a discordant coastline. All of those rocks are being eroded by the sea at the same time, but at very, very different rates. And you can see that places like Studland and Swanage Bay, which are made out of that much softer rock, have eroded quite quickly to form these bays, where Ballard Point, made of chalk, and Durlston Head, made of the hard limestones, have eroded much slower and left these big outcropping headlands that we can see, especially out towards Ballard Point. Those two little bits on the end that you can see at Ballard Point, that's actually Old Harry and Old Harry's wife, the stack and the stump that we mentioned last time out. Now, a concordant coastline we also have. If you kind of look at this coastline from the bottom of the screen, so what would be kind of from south to north, now from this angle, all of those rock plains are actually lined up parallel as you move back from this south coastline. You get the limestone, then further inland you get the clays, then the chalk, then the clays again. So down on that bottom coastline, the southern coastline of the Isle of Purbeck, we get a concordant coastline. Now you'll notice that there are some little indentations along this coastline, but what we don't get along these concordant coastlines really is that idea of big headlands and bays developing, because for that you need that differential erosion of a discordant coastline. On a concordant coastline, you have one type of rock facing the sea, and therefore that one type of rock slowly erodes dominantly all at the same rate. So you don't get the same features. However, we do, excuse me, get the idea of things like our wave cut platforms and cliff retreats, that very first landform that we looked into last week. Because the entire section of coastline is eroding at the same rate, you get that undercutting, those wave cut notches, the collapse of cliffs, and the development of our wave cut platforms that we looked at. Now, to make a little bit more sense of this, in terms of features, we're going to have a little bit of a think about the Gower and actually how the geology of the Gower plays in to create the landforms that we have. Because if you look at the Gower in general, along the south coast, we have a very obvious setup of headlands and bays. You have Port Einan Point, Oxwich Point, the cliffs at Pennard, and Mumble's Head as big kind of outcropping headlands. And in between them, you have Port Einan Bay, Oxwich and Three Cliffs Bays. You have Caswell and Langland, and then Swansea Bay itself as these big bays between the headlands. And we have the same, if you think about it, with Rossilly and Worm's Head, and then Bury Holmes up at the top as two headlands with a big sweeping bay that is Rossilly Bay in between. Now that would suggest that these areas are discordant coastlines. Oxwich Point and Port Einan Point must be harder rocks and more resistant rocks than, say, Port Einan Bay and Oxwich Bay are made of, to allow us to have that formation of these headlands and bays. Same with the fact that Rossilly Bay must be made out of something slightly different to Worm's Head to allow that headland and bay formation. But as we said last week, this area from kind of Mutlade and Fall Bay down towards Port Einan is a very straight section of coastline. We don't have really headlands and bays along it, but we do have this really big wave cut platform. That would suggest that that section, the kind of southwest coast of the Gower, would be more of a concordant coastline. All of those rocks are eroding back at the same rate. Now, if we turn this map into kind of a basic geological map of the Gower, what we actually end up with is something like this, and it does prove what we were just talking about. Now, I don't expect you to know all of these types of rocks. I don't expect you to remember all of these types of rock, but there are a couple that become quite important. In particular, this dark green color are Carboniferous limestone, which makes up the majority of the Gower, and also this little millstone grit, the kind of, I don't really know what you would call that color, but it's kind of a stretch down in there where we have Port Einan Bay, and there's a stretch down where we have Oxwich Bay as well. Now, if you look at it in this fashion, what we kind of just said is actually very truthful. The south coast of the Gower is a discordant coastline. If you walked along that south coast of the Gower, you would go from Carboniferous limestone to millstone grit, back to limestone, back to millstone grit, back to limestone again, and you would have this alternating pattern. Now that, as we said, is what you get with a discordant coastline, and it usually will allow the development of headlands and bays to start forming. Same goes if you look up at Ricili. We have our Carboniferous limestone out at Worm's Head. As you drop down onto Ricili Beach and Llangennith Beach, you end up in what we call Devonian Old Red Sandstone. Then as you go towards Bury Holmes, you end up with that idea of Carboniferous limestone again. So just like on the south coast of the Gower, out on the west coast, we also have this discordant section where you have rocks alternating perpendicular or at right angles to the coastline itself. And if we look at that southwest stretch, that entire section of coastline where we had our big wave cut platform is all Carboniferous limestone. If you start moving back from it, then you reach the Millstone Grit as before, and then back into the Carboniferous limestone again. So you do end up with this southwest section being a small concordant coastal section. Just along here, the rock runs parallel to our coastline rather than perpendicular or at right angles like it does everywhere else. Now, what we can do with this is actually start beefing up the explanations that we've had before in terms of things like wave cut platforms and things like headlands and bays to go along with it. Knowing what the geology is that we're dealing with, we can kind of put it into a little bit better detail. So if you think to the idea of headlands and bays that we had before, it was a relatively basic, relatively straightforward explanation that we had, if you remember back, or if you look into the booklet. In the booklet, you don't have the numbers 1, 2, 3, and 4, and you don't have due to wave refraction written along it. But it was a relatively straightforward explanation. We have these more resistant rocks, we have these less resistant rocks, and because of the way that they're aligned, it means that this is a discordant coastline. The sea is out to the right, and you have those perpendicular layers of rock. Now, in terms of the Gower, we know that that more resistant rock will be our Carboniferous limestone. That is the big, hard rock which creates a lot of headlands. Wherever we saw the bays on that last image, if we flip back to it a second, wherever we had the bays was dominantly that idea of Millstone Grit. So we know that the less resistant, softer rock out on the Gower is that Millstone Grit. Now, because of that, we can just start bringing those sorts of words into a description if we were going to be doing this in an exam situation. Now, if you wanted to, just like with tectonics, you could draw out a diagram like this if you wanted to, or you could just kind of write it out in full. And actually, these kind of 4 explanations are pretty much everything you need, as long as you can insert the right words into it. Now, the reason for the 1, 2, 3, and 4 is that they are the order that this would kind of go in. So if you look at it, the first one, you would say that bays have formed due to the rapid erosion of less resistant rocks. Then you would say that headlands are left sticking out as rocky outcrops where hard rock has resisted erosion. Then move on to number 3. Once formed, the headland is left more vulnerable to erosion and wave energy is concentrated here. Now, I've added that little bit because we know from the last booklet that wave energy is concentrated at headlands due to wave refraction. The idea of waves bending in towards, excuse me, the headland. And then finally, when formed, the bays then become sheltered by the headlands and so less eroded than they were before. And that's a relatively straightforward explanation. But what we can do, as I mentioned, is beef it up a little bit by bringing in the names of these actual rocks. So if you think about it, where it's got bays are formed due to rapid erosion of less resistant rocks, well, on the Gower, we know that that less resistant rock is millstone grit. So if you were writing it out in an exam, you could say that bays are formed due to the rapid erosion of less resistant millstone grit. Headlands are left sticking out as rocky outcrops, where harder Carboniferous limestone has resisted erosion. You just plop the name of the rock right in there and it makes perfect sense. Now, obviously, you would need to add a little kind of intro to it. So what you could use is something along the lines of this. Now, this will all make sense in a second when I put it up as a big question. If you were going to introduce this, if you were asked in an exam to say, making reference, just like the question before, making reference to one or more examples, explain the formation of headlands and bays on our coastlines. You could start off with something like that. Headlands and bays are an example of an erosional landform caused by a combination of rock type and rock orientation. The discordant alignment of the resistant carboniferous limestones and less resistant millstone grit of the Gower has led to the formation of Oxwich and Port Eynon headlands and bays. Now, obviously, that first little bit that goes into the idea of rock type and rock orientation might seem a little bit confusing. But if you think about it, rock type is just, well, what are they made of? Carboniferous limestone and millstone grit. And the rock orientation is making reference to the fact that it is discordant along the coastline. So if you were going to answer a question like the one that is now up on the board, with reference to one or more located examples, explain how rock type and structure influence the development of coastal landforms. We could start off with the little intro that we just had, but then tie in that little kind of 4-point explanation of headlands and bays, but just making reference to the type of rock. So you've mentioned Oxwich and Port Eynon headlands and bays, so you've named your example, you've named the types of rock as well, and you've said that it is a discordant coastline. From there, you just start name dropping. So if you think about it, that very first point was bays have formed due to the rapid erosion of less resistant rocks, where if you look at it, bays such as Port Eynon and Oxwich form due to the rapid erosion of less resistant millstone grit. That first half of a sentence is the first section of the description from the booklet. All I've done is named the bays, and instead of just having less resistant rock, I've named what that rock is. Second part of this sentence after the comma is the second section. I've just said that the more resistant rock is Carboniferous limestone, and that creates things like Oxwich Point. I've named the landform of the headland. And then, to be honest, the last two are generally just point 3 and 4. Headlands are then more vulnerable to erosion because of wave refraction, and the bays are now more sheltered, so experience little to no erosion, and if anything, actually deposition will start taking over. So it's relatively simple to kind of get these explanations up to the level that we need them. Now, last time out, when we were talking about mucilage and I showed you the answer from this, now the top bit of that answer should make sense, because I said at that point a wave cut platform is a landform of weathering, erosion and mass movement which can be seen along the Carboniferous limestone cliffs of Mucilade. Well, now we do know that that is a Carboniferous limestone because we just talked about that bit. And at the same time, if you think about it, you could start adding in things like that actually it can be seen along the concordant Carboniferous limestone cliffs at Mewslade. We know that that section of cliff line is concordant. The rocks are just running parallel to the coastline itself, and therefore you could always chuck that little bit in as well. But like I said, it's actually a lot simpler sometimes than people often think. The idea of just dropping these words into a relatively bog standard explanation can actually take it right up to the level that we need. It's all about the details, and therefore if you can talk about what the rocks are and you can talk about what the orientation is, then you're pretty much sorted. Now, this is part of the reason why a lot of what we do is going to be based around the Gower, because that way you only really have to remember a couple different types of rock. The Carboniferous limestone and the Millstone grit are the only two rocks that you actually need to remember. The hardest bit is remembering which way round they are. The fact that the Carboniferous limestone is the harder, more resistant rock that erodes very slowly. Millstone grit is a softer, less resistant rock that erodes much more rapidly. And if you can keep that in your mind, then you're usually on to a winner. Now, the Gower itself, in terms of its geology, gets relatively straightforward. There are places that get a little bit more complicated. And this stuff we are dominantly going to wait till when we are eventually back in college to have a decent look into, because we need maps and there's images that I need to bring up, and it doesn't really suit itself to this kind of virtual remote learning world that we're in at the moment. But usually this is part of the coastline down in South Dorset where we would go on the field trip. And we have places like Durdle Door, which is the big archway that we looked at before. But if you look at it, each of these colours is a different rock type, and the whole section of this coastline is one big concordant coastline. There is a very solid rock, something called Portland stone, right out towards the sea. Then you have a layer of what we call Purbeck beds, which are a slightly softer form of limestone. You then have some Wealden clay and green sand, which are really, really weak and erode really, really quickly. And then you have a massive, great section of chalk off at the back. Now, the way that this coastline now looks is all to do with the erosion of this concordant coastline. It's given us lots of strange little features like Durdle Door itself, a place called Man o' War Bay, and also the idea of a place called Lulworth Cove and Stairhole further along the coastline, because of the fact that this is a relatively unusual little coastline. Now, if we think about it, this is kind of Durdle Door as we saw it last week, and how most people think of Durdle Door, this big archway sticking out into the sea. Now, what makes this coastline really strange, and as I said, it's something that we'll go into more once we're back in college, is that isn't technically sticking out to sea. Durdle Door actually sticks out sideways. It actually runs parallel to the coastline. It doesn't stick out from it. The little outcrop where the actual archway is, if you look on this map, is actually the little section right where my mouse is over on the left hand side. The archway sticks out from right to left on that little headland. It's actually completely sideways to the coastline, and if you look at it from another angle, you get a better idea. The fact that it actually juts out across this little bay rather than straight out to sea. Now, this is the dominant landform that we're going to use to start describing the idea of caves, arches, stacks and stumps in more detail. once we get back into college, because we have the big archway. There is a little stack off in the distance which you can't really see. It's called Butter Rock, that little tiny stack out there. There is a dinky little archway out in the headland that side as well, and we also have a couple of stumps. You can see one big one sticking out there. There's actually a run of 3 relatively big ones that get submerged partially as the tide comes in. So we're going to have a little bit of a closer look at this one when we can eventually get back into college properly. If you look at Durdle Door from the other side of the little headland that it's on, you get a similar sort of makeup. That is basically the rear end of Durdle Door. That is its backside. And again, you can see these little lumps of rock which are made out of the exact same thing that Durdle Door is, sticking out across the coastline. And again, if you look at this bit from a slightly different angle, you start to actually see how all of these different rock types are kind of interacting along the coast almost. But as I mentioned at the beginning, this one is easier to do face to face because we can get out the maps properly. We can look at all of the images of some of the previous trips to Dorset, and you get a much better visual of it. So there are some bits and pieces that we'll do properly with it once we get back. Right, the last thing that I want you to have a bash at this week is a couple of little questions that are at the end of the booklet. I appreciate, as I've said, there are a few bits that we've jumped over. Don't worry, we will come back to those once we can get into college and sort them all out. But if you look at the very back of the booklet, there is 3 questions. Actually, technically 4 questions. And those I would like you to have a little go at. They start off with this one, Figure 2, erosion of the UK coastline. So the first question just wants you to calculate the percentage of coastline which is eroding in Wales, and it wants you to show your working. It is just a little maths question just to check that you know how to make a percentage. If you don't, look it up, then work out the question. Part 2 of that question on the next page says, use Figure 2 to describe the extent of coastline erosion in Wales compared to that in Scotland. So you need to answer the first bit first to get the percentage. Then you need to compare that to the actual rate that is in Scotland. Part B, which is another little 3-mark question, I don't want you to worry about just now. We will skip over that one for now and might come back to it later. It's a little bit of a pointless question, that one. But finally, part C is a big 9-mark question where it says, with reference to one or more located examples, explain how rock type and structure influence the development of landforms of coastal erosion. Now, we've done that actually for both today already. So you don't really need to have a full-blown go at the question. However, what can be useful is to have a look back through on this PowerPoint, the answer to the question about the wave cut platform at Muslade. Have a look at the answer for headlands and bays at Oxwich and Port Eynon, and just make sure you are completely happy with how they would come together to answer this question. What is in that introduction? What is changed about those explanations that is in the booklet in terms of where the rocks come in, where the orientation of the coastline comes in to actually, and where those erosional processes come in to really make good in terms of that answer. So it is just a little bit of a space to Yeah, get to grips with how we answer these questions. If you find it helpful to just write something out, then by all means write the answer out in that space. If you're somebody who prefers to just make little notes or a little kind of flow diagram of what order things would need to come in, that's absolutely fine. Like I said, question C we have done for 2 different landforms in this PowerPoint. I just want you to use that space to do something to make sure you're happy with how we get to those slightly bigger answers. Because to be honest, all of the large coast answers are like this. They will focus on an erosional landform or a depositional landform, and it's about having that sequence of unpacking the question, naming the example, then going through that step-by-step formation, but making sure you're inserting the right terminology, the right names of processes, the correct rock types and names of places for your examples at the same time. So a relatively short one today, but that takes us nicely up to the booklet. So all I want you to do is have a go at those first 2 questions, then use the space for question C to get that answer solidified in your head. Now, we won't go any further today because that technically brings us to the end of this booklet for the time being. Now, obviously, potentially next week we might be back in, though it is starting to look more and more doubtful the more and more you see the news, but we never know. If we are not back in, we will start the next booklet next week virtually, and just start plowing through it until we're back in the way that we should do. But for me, for today, that's it. You've had a watch of that first video. If you didn't, go back and have a look at it. We've had a little bit of a chat through how some of this stuff can be transferred into questions. Now I want you to just go and have a little bit of a blast at those questions that are in the back. If you have any questions, let me know, send me an email or send me a message on here and I will get back to you with any answers. But for me, for today, that is all I require from you. So